Hello, and today I'll be explaining the group anagrams problem. This is a pretty fun one that I enjoy because I feel like the trick that really gets you to the solution is a really nice and creative one. The task is to group an array of words into their anagrams. For example, when we get this array of eat, tea, ten, eight, net, and bat, we group the words into other arrays so that each word in the array is an anagram of all the other words in that array, or it's a unique word with no other anagrams that can be found in any of the other arrays. So we have an exclusive bat, we have nat and tan placed together, but no other anagrams of tan or nat found in any other arrays. Anyways, let's just jump right into it. So I expect you to be already slightly familiar with how we find anagrams in the first place, because if we're not able to do that, we can't really move on to the problem in general. There are two simple ways to do that. One is to simply sort them. In this case, we could both sort E and T in alphabetical order, and we would both get AET, and then we would know that they're an anagram. And as a quick review, that would have taken O of n log n time, because sorting takes O of n log time even with the fastest sorting algorithm. But there's also another way in which we can create a hash map by keeping track of the amount of occurrence of each letter. In this case, we could create like E pops up once, A pops up once, T pops up once, and we could compare that to T and we would get the same exact result. Now, there is actually a problem with our hash map one. The reason why is, how would you group something together by hash maps? One way I would like to think about this is that if we actually sorted it, we could actually group like EAT, eat, and T in the category and give it like AET, and then it would be pretty easy to group them all, and let's just say a hash map in which we could basically make AET a key and then the value of all the words, in this case eat and T. But if we're gonna do the same thing with our hash map counter, we run into a big problem. The first problem is, look, you can't just store a hash map as a key for another hash map. Unfortunately, it doesn't work like that. And you might be thinking, what if we could try a trick to like group it together? And so instead we could have like E1, A1, T1. But you might see another problem about this, because when we look at T, our key would have been T1, E1, A1, and these would not have been grouped in the same part of the hash map. But then we actually get a very nice trick, because we know that these words, the only possible characters are from A to Z. And if we think them of the position of the alphabet, we would get 0 to 25th, with 0 being A, 25th being Z. So what if we actually made it so we stored them not as in like A1. Instead, we could make an array in which simply the first element would be 1, showing that the 0th position, which indicates the letter A, has 1 occurrence of it, and then we could always increment that later if we saw another A to get a 2. And another neat thing about this is we can then convert this into a tuple, which allows us to finally store these as keys. So that means we could basically create a 26 elements array, and basically each position, ith position, indicates the ith position of the alphabet, and then the value of certain number I equals the amount of occurrences. And afterwards, we can directly compare these, because eat would get the same result as T, because we don't have to worry about being in the right order because we're basically editing a certain position of already a fixed array, if that makes sense. So that is a way to group our anagrams into basically different areas of hash map, and then we can finally return them as groups. So let me show you this in code. Another fun language to speak that will hopefully make you understand the problem even better, and even just show how to implement it. So the first thing we're gonna have to do is import a default dictionary class. I'll explain why. What's just gonna do is help us work with our edge cases. So let's create a dictionary and let's call it anagram groups, and we're just gonna make a default dictionary where it's a list. And basically what this thing is, create a dictionary, and by default, if we want to assign a certain index to it, it'll no matter what already start as an empty list, which means we could append to it without throwing any errors. The next thing we want to do is iterate through each string, and we unfortunately cannot call this string because that is its own keyword in Python. Let's call it s. And now we need to create our key, which will be 0 times 26. And if you're not familiar with Python syntax, this just means I want to create 26 elements in a list, each of them being 0. It's pretty easy to do compared to other languages. And now we're going to have to loop through each character of the string. And this is where we're going to have to figure out the position of it in the alphabet. And it's actually not that hard. All we have to do is take the order of C minus the order of a lowercase a. And then finally, we're going to say that the key of this position will now be incremented by 1. And remember, these are all like by default like 0, in the same way that this will be all by default lists. Finally, all we have to do is say that our anagram groups with the certain key of our tuple conversion of our original key, which is a way to get around not being able to store a list as hash map keys or dictionary keys. And then we can finally append our string. That was a mouthful. And finally, I believe all I have to do is return our anagram groups values. It's been a bit since I've done this problem. Let me try. Oh, I have a slight typo too. Oh, it turns out that the values is actually a method, so let's fix that. Now let's submit the code. Hey, and it beats 70% of other code in time complexity, but unfortunately it's not great in memory. We can see we have of n times m. In this case, I believe m is simply the largest possible length of a character. And if we go to memory, we will have n times m. And because I'm a nerd, I also decided to try this code out with a different approach in which we actually group them by the sorted string, which is the solution I explained earlier. Obviously, the time complexity will probably be O of n log n times m, but we're not allowed to see that, but the memory is a lot faster. But I just wanted to try out the different ways because this one is probably a lot more memory efficient as we don't have to store such large keys. But either way, it's a pretty fun problem in my opinion, and I like the approaches. Anyways, if this video helped you, please give me a thumbs up. Hopefully you subscribe. Like always, bye-bye.